Number 10. Earth sits in the most suspiciously convenient spot possible. Earth's position in space is often explained using the phrase habitable zone, but that phrase makes it sound far more common and forgiving than it actually is. The habitable zone around a star is an extremely narrow region where surface temperatures allow liquid water to exist for long periods of time. Outside that zone, planets either lose their water entirely or lock it away as permanent ice. Earth sits almost perfectly in the middle of this zone, not flirting with the edge, but comfortably settled in the safest possible range. What makes this more suspicious is how stable Earth's orbit is. Many planets have elongated or chaotic orbits that cause dramatic temperature swings over time. Earth's orbit is nearly circular, which means the amount of sunlight it receives stays fairly consistent year after year. That stability matters more than it sounds. Early life is fragile. If temperatures swing too wildly, chemical reactions stop working properly, and early organisms never get the chance to adapt. The sun also plays an important role here. It is not too big, not too small, and not overly violent. Many stars release frequent bursts of radiation that would constantly damage a planet's surface. Others burn through their fuel too quickly to support long-term evolution. Our sun provides steady energy over billions of years, which is exactly what complex life needs to slowly develop. When you combine Earth's precise distance, its stable orbit, and the sun's calm behavior, the result feels less like random luck and more like a carefully balanced setup. Earth was not just placed in a good location, it was placed in a location that stays good long enough for intelligence to eventually emerge. Number 9. Earth has liquid water and an almost unreasonable amount of it. Water is often described as essential for life, but that statement does not fully capture how rare Earth's situation actually is. Earth does not just have water. It has vast, deep oceans that have remained liquid for billions of years. Most rocky planets either lose their water early due to weak gravity or never maintain the right temperatures to keep it liquid for long.
The timing of Earth's water stability is crucial. After the planet cooled from its violent early formation, temperatures settled quickly enough for oceans to form and remain stable. Once those oceans existed, they acted as giant climate regulators. Water absorbs heat slowly and releases it gradually, which smooths out temperature extremes across the planet. This gave early life a relatively calm environment instead of a constantly hostile one. Water also makes chemistry easier. It dissolves minerals, transports nutrients, and allows complex molecules to interact without breaking apart. This turned Earth's oceans into massive chemical laboratories where life could experiment over enormous spans of time. Early organisms could fail, mutate, and adapt without being instantly wiped out by environmental instability. Even ice behaves in a strangely helpful way. Ice floats, forming an insulating layer on top of water that protects what lies beneath. This prevents oceans from freezing solid during cold periods. If ice sank instead, Earth's oceans would have frozen from the bottom up, likely ending life early on. Instead, water quietly protects life through physical properties that seem almost perfectly aligned with survival.
Number 8. Earth's atmosphere functions like a built-in life support system. Earth's atmosphere is one of the most overlooked reasons life exists here at all. It is not just a layer of gas, it is a carefully balanced system that performs several critical functions at the same time. Nitrogen stabilizes the atmosphere, oxygen supports complex organisms, and carbon dioxide helps regulate temperature. Change these ratios even slightly, and life becomes far more difficult. The atmosphere also acts as a protective shield. Most meteoroids burn up before reaching the surface, and harmful ultraviolet radiation is filtered out before it can damage living tissue. Heat is spread around the planet through winds and pressure systems, preventing extreme temperature differences between day and night. Oxygen is especially interesting. It is a highly reactive element that normally disappears by bonding with rocks. On Earth, oxygen exists in large amounts only because living organisms constantly replenish it through photosynthesis. This creates a feedback loop where life maintains the atmosphere and the atmosphere supports life in return. That kind of balance is rare and fragile.
Clouds add another layer of control. They reflect excess sunlight to prevent overheating while also trapping heat to prevent freezing. The atmosphere behaves less like a random collection of gases and more like an active environmental system that constantly adjusts to keep conditions stable. Without it, Earth would look far more like Mars than the vibrant planet we know. Number 7.
Earth's magnetic field quietly saves the planet every day. Earth's magnetic field is invisible, but its absence would be catastrophic. This field deflects charged particles from the sun and blocks much of the dangerous radiation that constantly moves through space. Without it, Earth's atmosphere would slowly be stripped away, leaving the surface exposed and hostile. The magnetic field is generated by Earth's molten iron core, which acts like a massive dynamo. For this system to work, the planet must maintain internal heat for billions of years. That is not guaranteed. Many planets cooled too quickly or never developed a strong magnetic field at all. Earth managed to stay active just long enough to protect its surface during life's most vulnerable stages. This protection also preserves genetic stability. High levels of radiation damage DNA and increase mutation rates beyond safe levels. While some mutation is necessary for evolution, too much leads to biological collapse. Earth's magnetic field keeps radiation levels low enough for slow, controlled evolutionary change. What makes this even more suspicious is how consistent the magnetic field has been. It has weakened and reversed at times, but it never disappeared for long. That long-term protection allowed life to gradually move from oceans to land and eventually develop complexity. Without this invisible shield, Earth's surface would likely be sterile today. Number 6. Earth's gravity is balanced in a way that almost feels intentional. Gravity is one of those things that seems simple until you realize how many systems depend on it being just right. Earth's gravity is strong enough to hold on to a thick atmosphere and vast oceans, but not so strong that it crushes complex life or turns the planet into something closer to a gas giant. That balance is incredibly narrow, and Earth sits directly inside it.
If Earth were significantly smaller, its gravity would be weaker. Over time, solar radiation would strip away the atmosphere just as it did on Mars. Without enough air pressure, liquid water would evaporate or freeze, and surface life would struggle to survive. On the other hand, if Earth were much larger, gravity would be stronger. The atmosphere would become thicker and heavier, making it difficult for complex organisms to breathe or regulate body temperature. Gravity also shapes biology itself. Muscles, bones, and circulatory systems evolved specifically to function under Earth's gravitational pull. Blood flows efficiently without requiring extreme pressure. Bodies can grow large without collapsing under their own weight. Even something as simple as walking upright depends on gravity falling within a specific range. Gravity also affects the behavior of water and gases. Rain falls gently enough to nourish ecosystems rather than destroy them. Oceans remain deep, but not crushingly pressurized near the surface. The sky stays where it belongs instead of slowly leaking into space. All of this works together in quiet ways that rarely get noticed. When you step back and look at how many things depend on gravity being exactly what it is, it stops feeling like a background feature. It starts looking like one of the main reasons Earth works at all.
Number 5. Plate tectonics keep Earth alive instead of letting it die. Earth is not a static planet. Its surface is constantly moving, breaking, colliding, and reshaping itself through plate tectonics. This process may look destructive, but it is one of the main reasons Earth has remained habitable for billions of years. Without it, the planet would likely be either frozen solid or overheated beyond recovery. Plate tectonics act like a massive planetary recycling system. Carbon dioxide is released into the atmosphere through volcanic activity and then slowly removed as it becomes trapped in rocks. This long-term cycle helps regulate Earth's temperature. When the planet cools too much, volcanic activity adds warming gases. When it heats up, those gases are gradually removed. Tectonics also bring essential nutrients to the surface. Elements like phosphorus and iron are constantly recycled from deep within the planet and spread across continents and oceans. Life depends on these materials, and without tectonic activity, ecosystems would eventually run out of critical resources.
The movement of plates also creates environmental diversity. Mountains, valleys, coastlines, islands, and deep ocean trenches all exist because the crust is alive. This variety creates countless habitats where life can adapt and specialize. More environments mean more evolutionary pathways. What makes this suspicious is how rare plate tectonics may be. It requires the right internal heat, the presence of water, and a crust that is neither too thick nor too thin. Earth somehow met all these conditions at the same time, and it has kept them going for billions of years. Number 4. The moon is quietly stabilizing Earth behind the scenes. Earth's moon is far more important than it appears. It is unusually large compared to the planet it orbits, and that alone makes it strange. This size gives the moon the ability to stabilize Earth's axial tilt, which keeps seasons relatively predictable over long periods of time. Without the moon, Earth's tilt would vary chaotically. That would cause extreme climate shifts, where polar regions might suddenly face intense heat, while equatorial regions freeze. Such instability would constantly disrupt ecosystems and make long-term evolution far more difficult.
The moon also controls tides, which do much more than move water back and forth. Tides mix nutrients in the oceans, supporting marine ecosystems. They create dynamic coastal zones where early life may have transitioned from water to land. These constantly changing environments encourage adaptation and innovation. The moon's origin is also oddly convenient. The leading theory suggests a massive collision early in Earth's history. Somehow, that impact did not destroy the planet. Instead, it created a moon positioned at exactly the right distance. Too close and tides would be catastrophic. Too far and they would be useless. The moon acts like a silent partner, keeping Earth stable and biologically active. It rarely gets credit, but without it, Earth would be a far more chaotic and hostile place. Number 3. Earth's chemistry seems unusually friendly to complexity. The chemical environment of Earth is not just suitable for life, it actively encourages complexity. The most important elements for biology are abundant and easy to access. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur all exist in forms that readily combine to create complex molecules.
Carbon is especially important. It forms strong, flexible bonds that allow for enormous molecular diversity. While other elements could theoretically form like structures, none match carbon's ability to build stable yet adaptable systems under Earth-like conditions. Earth's temperature range also supports chemical stability. Molecules can form without instantly breaking apart or freezing solid. This allows biological systems to grow more complex over time instead of constantly resetting. Water further enhances this process by acting as a solvent, bringing molecules together and allowing reactions to happen smoothly. Energy is also available in many forms. Sunlight, geothermal heat, chemical gradients, and electrical activity all provide ways for life to power itself. This diversity of energy sources makes ecosystems resilient and adaptable. When you put all of this together, Earth's chemistry feels less like a random outcome and more like a welcoming environment for complexity. The ingredients are common, but the conditions that allow them to build something as intricate as life are anything but.
Number 2, Earth had enough time, calm, and second chances for life to grow. One of the most underrated reasons Earth supports life is not just where it is, but how long it stayed stable. Life does not appear instantly. It requires enormous spans of time to move from simple chemistry to complex organisms. Earth managed to remain habitable for billions of years without permanently breaking any of its life support systems. Early in its history, Earth went through violent periods. Asteroid impacts, volcanic eruptions, and atmospheric changes were common. Yet, after that chaotic phase, the planet settled into a long stretch of relative calm. That calm did not mean nothing bad happened. Mass extinctions still occurred, but they were spaced far enough apart that life could recover and even become more complex afterward. This balance between destruction and stability is important. Too much chaos and life never gets past simple forms. Too much stability and evolution slows down. Earth somehow landed in the middle, where disasters reshaped life without completely wiping the slate clean.
Earth also avoided irreversible failures. The oceans never boiled away permanently. The atmosphere never collapsed completely. The magnetic field never vanished for too long. Each time the planet was pushed toward the edge, it pulled back before crossing the point of no return. Time is one of the rarest ingredients for life. Earth did not just have it, it protected it. That long, uninterrupted window gave evolution the space it needed to eventually produce intelligence that can now question how all of this happened. Number 1, the more we learn, the less Earth feels like an accident. When you look at any single factor that makes Earth habitable, it is easy to call it luck. But when you stack all of them together, that explanation starts to feel less satisfying. Earth's location, its water, its atmosphere, its magnetic field, its gravity, its tectonics, its moon, its chemistry, and its long-term stability all work together like parts of a single system. Each factor supports the others. Water helps regulate the climate. The atmosphere protects water. The magnetic field protects the atmosphere. Plate tectonics stabilize temperature. The moon stabilizes Earth's tilt. Remove any one of these and the entire structure becomes weaker or collapses entirely.
This does not automatically mean Earth was designed, but it does suggest that truly life-friendly planets may be far rarer than we once thought. The universe might be full of planets, yet very few that can maintain this level of balance for billions of years. As we discover more exoplanets, we are finding many worlds that are close, but not close enough. Too hot, too cold, too chaotic, or too unstable. Earth keeps standing out, not because it is perfect, but because it is consistently good in every category that matters. The uncomfortable possibility is that Earth is not just one of many. It might be an exception. And if that is true, then life like ours may be far more fragile and far more valuable than we usually realize. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them.